Hey, welcome everyone. We're excited to be here with you today. I'm Vikram Rana from Azul, and I have my colleague Eric Koslow. Eric runs product for Azul Intelligence Cloud. Azul Intelligence Cloud uses production runtime data from JVMs to continuously detect vulnerabilities in Java applications. Eric comes from the security background. Eric, would you please tell us a little bit about yourself?
Always happy to do it. So my name's Eric. I have quite a good set of security knowledge, mostly in the vein of application security, but specifically within the domain of application security, my specialty is Java application security. So dealing with JVMs. So I write a lot of Java code. I reverse engineer a lot of Java code, and usually for good things.
Well, that's cool. Eric, so let's start off with something fun that you introduced. It was this Toothbrush botnet, supposedly written in Java. We added that in the intro. It's kind of weird, but fun. What really happened there from a security perspective?
Yeah, the whole point of the Toothbrush botnet, or at least now, is just that it's a funny story. So a couple weeks ago, there was this suite of articles that went around through some U.S. publications as well, that said there was a big Java-based toothbrush botnet that was taking down websites in a couple other countries, and it originated over in Germany. So I looked at that and I said, okay, it's perfectly believable that there's a botnet of toothbrushes that's taking down websites because I've seen companies get hacked before through fish tanks, and the target breach came in through the HVAC system. So IoT breaches, run of the mill. Also, the news article for that toothbrush was based in Germany, where there happens to be a lot of embedded Java development going on a lot of embedded devices. So the idea that somehow there was a toothbrush-based botnet taking down a bunch of different websites that somehow involved Java, pretty believable. And it turned out that that was actually not a true story. Instead, it was kind of a couple articles that came together where a reporter misunderstood some things. And the thing that gave it away is that they said it was a Java-based operating system, which there isn't one. So the idea that Java is powering your toothbrush that you use to clean your teeth every night and in the morning, and hopefully also after lunch, pretty believable. But the idea that there's a Java-based operating system, less so.
Yeah, really funny story there. Thanks for debunking that one, Eric. Well, let's move on to something that's much closer to home to a lot of DevSecOps and DevOps and application security professionals, and that's the ever-present Log4j. Is Log4j still a problem?
Unfortunately, yeah. I wish I could say that Log4j was not really a problem anymore, although I do really like the logo that's up here, especially when people make these Microsoft Paint logos for vulnerabilities. I find them funny. They take the edge out of something that's actually kind of serious. You should wish that people weren't vulnerable to Log4j, but I think it was Veracode that came out with a report a couple months or month or so ago that said it's still in like 1 in 3 applications or something that's pretty high. Yeah, it's around everywhere. I know a lot of people have put a lot of defenses up into place. A lot of us want to think that we've dealt with it. Maybe a lot of us are dealing with it. But unfortunately, Log4j is just the gift that keeps on giving.
Yeah, so you come from that community of application security and DevSecOps and Java, that intersection, and you lived it, right? You were on the ground. You're on ground zero. And you called it the December to remember back in 2021. What did people do right away during the Log4j event?
Yeah, it was a great time. One of the big things that a lot of people did was they went to Twitter at the time and panicked. There was just a nonstop stream of feeds of people who were like, where is this? I don't know where this component is. Oh my God, this component is in everything. Back then, when I was looking, it was like 70% of applications had a vulnerable version of Log4j. And what was really bad about it is it was really, really, really easy to exploit. You gave somebody a particular string. Then when the JVM went to log that string, it would go try to download code. So a lot of people spun up code givers, and they would just send that string around and then try to tell other people's JVMs to download code from them. Really easy to exploit everywhere. I remember getting on a couple large public panels at the time where they're just like, Java, get up there. So it was entertaining. Otherwise, how did people deal with it? Well, they've set up two things. One is for a lot of systems, they use vulnerability management scanners that go log into different systems, try to list out the jar files that are on the system. And when they find a version of log4j, they flag it. The other thing is for newly built applications, you try to keep it out of production systems by having a lot of code at the build cycle where you see, am I going to ship a vulnerable version of log4j? But there's two problems with that. One, a lot of the existing applications that aren't under active development don't go through those pipelines anymore, so you don't have a way to catch them. And two, if you're looking in your production systems for it, a lot of Java applications use a technique called shading, which the file that's called log4j.jar, it's not there. So when you go to look, you don't find it.
Yeah, it's really interesting. And, as Java developers, there's a vast ecosystem of open source libraries. You told me it's in the millions. And developers typically comprise their applications from that. And there are a lot of popular open source frameworks that are just as pervasive as Log4j. What other libraries and frameworks could be hacked as bad or somewhat as bad as Log4j?
Yeah, there's a lot of Java applications and different libraries that people use. Spring is another really popular one. And shortly after Log4j, there was a Spring 4 shell. Log4j, everybody called the exploit Log4 shell. So they had an exploit in Spring. So they created Spring 4 shell. It's just a lot of these libraries tend to pop up and become vulnerable at any given time. And I wish I could say that it was a lot better. You can deal with it, but it's work to kind of keep up with these security vulnerabilities. The library that can't seem to catch a break, though, is Struts 2. Those guys, I like the team. They're nice people. I want to say good things about open source, but just they seem to be getting hit a lot.
Yeah, well, it's interesting. You and I have talked about people that get misjudged inappropriately. For example, Quarkus, great framework for microservices, micro applications, cloud native apps. And people thought they were vulnerable for Log4j. Can you talk a little bit about what happened to them in that open source project?
Yeah, Quarkus is probably one of my personal favorite Java application development frameworks. You can build a lot of really good things really quickly, and the applications run really fast. So the Quarkus team has done a really good job. But back during the Log4j timeframe, remember, everybody looks for Log4j by seeing, do you have a copy of log4j.jar, either when they deploy it or when they go to build it. So a lot of Quarkus applications did have a copy of log4j.jar, but it was an API compatibility layer. It was just a jar file, a transitive dependency that happened to be there in order to resolve a couple of APIs. And the Quarkus team never actually used that library. So what happened at the time is everybody who would go through and they'd say, who's vulnerable to log4j? These Quarkus applications would show up. So everybody kept reporting to Quarkus and saying, oh my God, you're vulnerable. You have to fix this. But they were all wrong because those applications never actually loaded the library. So there were enough people who kept reporting exactly the same false report that said these applications are vulnerable, that the Quarkus team had to publish a blog and say, look, we're not vulnerable to log4j. Yes, we have a jar. However, a lot of Java applications contain a good portion of unused code because it's just a transitive dependency. Quarkus, sure, they could have patched it, and they did. But at the meantime, should you spend time worrying about that application? No. Go chase the people who are actually using the vulnerable library.
Yeah, and it's interesting. You mentioned the Bureau Code report, more than 1 in 3 production Java applications still use a vulnerable version of Log4j. And you mentioned that's typically in these larger monolithic applications, right, that developers don't necessarily want to touch. It's hard to change or update a library. I love one of your quotes in an earlier meeting. I hate code, right? A lot of developers hate code that they don't write. What would it take for folks with those large legacy code bases to update and remove vulnerable versions of Log4j?
Yeah, theoretically, all you do is you swap a jar and you update the build system, and then you're good to go. Log4j is a nice one because the APIs are relatively simple, but for some of the applications and libraries that people have to update because of security reasons, there's a lot of different testing that you have to do to make sure that the application still works. Because if you just go and you rip out an old jar file and you say, I'm going to upgrade from this version to that version, you can create some pretty bad compatibility effects where you end up breaking the application. So you have to go through a lot of testing. So a nice thing that people can do there is to actually go through and figure out, like, can I test this application? Does it work? But one of the things that people should do for that, especially if you have a large application, is, maybe you don't need a lot of that code. A lot of applications, they're, 1-2 million lines of code. What if you could just get rid of a lot of code that you wrote a long time ago, but no longer need?
Yeah, so it's really interesting. There's a lot of code that's written from former developers on the team, then they move off. How much of this code that you mentioned can people remove that they know about and understand? What % of this code is truly unused and not understood by the current teams?
Yeah, the majority of Java applications, like, there's code that was written a long time ago because some people were on the team and maybe you used it all in the beginning. You were lean and mean. But then over time, new people join the team. Some people leave the team. Maybe you change your functionality. So there's this portion of code that you wrote a while ago and you still run tests on it that it turns out, just due to the way that you changed the application, is no longer in use. So on the picture right here, we have kind of a pink or magenta portion that grows, which is parts of the code that we wrote, we test, we have to maintain, but it no longer runs. So it's just kind of a big old burden on the team. Ultimately, there's a joke amongst engineers that says the definition of being a senior engineer is just walking around saying it depends all the time, and then giving all the reasons as to why you can't give a clear answer. So, what portion of code is that pink section of code that is there that you don't actually maintain? I'm going to play senior engineer and I'm going to say, well, it depends. And it's just based on, did you comment out annotations? Did you change some logic flow? I can't say for certain whether it's, 10%, 20%, but I would say it's really rare that it's zero. And I would say, if you're under 10%, you're probably doing pretty good. So you're generally a little higher than there.
Yeah, I mean, when you say even in a large code base, that's a couple million lines of code and it's only 10%, that's still a significant amount, in terms of development time. If it's so big and there's so much tech debt, why is it so difficult to remove that code? Why is there so much unused and dead code?
It's ultimately, a lot of developers and engineering teams are measured on building new features and getting things out there. There's often not a lot of time allocated in schedules to go back and clean up old things or to kind of pay down some of that old technical debt. So when a team says, like, oh, can we get rid of some of our old code? They don't have time to do it. So they're always kind of delivering new things and putting more and more and more in. So what happens is, if you just say, I'm going to get rid of some old code, you have to really know what you're getting rid of. So can I get rid of this code? It's going to take me too long to figure out the answer to that question, because most of what people have to do, there's a lot of manual work of having log statements, using code analyzers to figure out what code can I get rid of. The cool trick now, though, is you can just make the JVM tell you what code it's using. So as you're running your application in production, you can report back all of the methods that you're using for the first call invocation. And then you can say, yeah, I actually used that method. And the best part about making the JVM track it for you in production is you can catch a lot of really old, outdated unit tests where you could delete the code, but when you delete the code, you make a test fail. But the only reason the test exists is because the code exists. Now you can actually get rid of them both.
Yeah, so let's move on, Eric, to what we talked about in the abstract and give teams some practical steps to take forward to make their lives easier and simpler. Let's start with kind of a retro framework in terms of DevSecOps and application security for Java apps. What are people doing today?
I think the things that people are doing today, which is, scan your applications in pre-production as you build it, see if you're vulnerable before you ship it. Those are good things. Periodically look over your production environment. That's good too. But ultimately, one of the reasons that Java is successful and a lot of people can do a lot with it is oftentimes the best thing you can do is just make the JVM do things for you. I don't have to manage the memory of my Java application. I don't really have to tune a lot of the performance of my application. I certainly do if I want to peek it. But I can get the JVM to just do a lot of things for me. So if I want to keep my application secure, why don't I just have the JVM report that information back to me about what it's running and if it's vulnerable?
Cool, cool. What about things people should stop doing? Going back to the retro framework, what are they doing today that they should stop doing?
Yeah, a lot of things that people should stop doing is just to kind of kick the ball over to a separate security team and say, oh, well, they're responsible for it, or to rely only on the build cycle security. Because if I'm working on the application, let's say the vulnerability didn't exist at the time that I built the application. Like Log4j, it was out there for 8 years and everybody had their applications in production. So the fact that the vulnerability wasn't known when I built it and it wasn't known when I scanned it, it's known now. So we still have to do something with it. So it's that whole role of making the JVM track what it's doing in production and bring that telemetry back. But the thing people should stop doing is thinking about security as a gate or something that you pass and then you wipe your hands and you say, it's secure from now until the end of time.
Yeah. So, and the final thing is, practical steps to take away in terms of getting tighter integration with security with DevOps and making it simpler and more efficient. Obviously, you mentioned turning on data or telemetry from the JVM, which it already has. Is there anything else you would say people should start doing?
I mean, my favorite thing in the realm of Java applications is just make the JVM do it. We don't need a lot of external tools. I can grab performance information. I can grab now security information from my running Java application. So don't do extra work. Don't do unnecessary work. Just make the JVM do what it can do and take advantage of what's already there.
Yeah, it feels like security should have been part of the JVM from the very beginning. And I think that's what you're saying. So that's great. Well, that really wraps up our LinkedIn Live Security episode for today. We want to thank you all for joining and feel free to reach out to us on our email addresses here. And thank you, Eric, for your time.
Thanks a lot.